All right, guys, welcome to Lesson 5. We're going to continue our discussion on u substitution. Today we're going to do u substitution with definite integrals. Those are the ones where you have the numbers here on the top and bottom. We're also going to talk about how to deal with the situation when you have an extra x left over. Even though you've done the u substitution right, there's still an x left in there. Remember, we're trying to get rid of the x's and replace them with u's, right? Sometimes you still have an x left over. And here's the thing about these problems. They're a lot of work. They're hard to get right. And they're not very common. But they do pop up. So it's worth talking about, but they're kind of a pain. And the only reason they're hard is because of the algebra. It's not the calculus, it's the algebra. But we'll get there. Anywho, let's go ahead and start off with the first one here. The first one's very important, very common AP type of question. Okay, so let's go ahead and begin here. Most of the process isn't different. There is one little twist at the end, and it has to do with these things here. Okay, so we'll get to that. But for now, let's go ahead and just do the integral like we're used to. We have an inside function with its derivative on the outside, or something that will cancel out the x's anyway, which is good enough. So start off by saying that setting u equal to the inside. Then we take the derivative of u with respect to x. Solve for dx. Do your u substitution. Now here I'm going to stop because this is where something different is going to happen. I mean, other than the fact that these are going to cancel, that's nice. But there's more, okay? Here's the thing. These are x values, right? That's x2. That's x1. Those are x values. But I just did u substitution where I got rid of all the x's and I put u in there instead. So it would be wrong for me to write 1 and 0 here because those are x values and we don't even have x anymore. Now it's just u's. So I need to change those numbers so that they're u numbers instead. And so how do you do it? And this is the key step. Okay, so I would make this little note. For definite integrals, we need to change the limits also. We need to change them to u values instead of x values. So now the question is, how do you do that? You're going to plug those values of x into this equation that you wrote. Okay, so for instance, this is x equals 1, so what's the u value that's going to replace that? Well, I'm going to plug 1 in for x up here. That's going to be 1 squared, which is 1, times 2 is 2. 2 take away 3 is negative 1. So now u is negative 1. So the top becomes negative 1. All right, same thing for the bottom. X is 0. What is u when x is 0? If I plug in 0 here, what will I get? You'll get negative 3. Okay, so that's the main step. Okay, that's the new thing for today. So for definite integrals, we also need to change the limits into u values instead of x values. How do we do that? By plugging those limits in up here. We'll transform them into u values. Okay? Since we're changing everything into u's, even the limits need to change into u values. All right, so now I'm going to erase all this. We have u cubed du with our limits -1 and -3. So let's go ahead and integrate. Remember, with definite integrals, we don't need a plus c. We put brackets and our limits on the side. Okay? Here's another thing when it comes to doing u substitution with definite integrals. When we did u substitution last lesson, we replaced the u with what u is equal to, right? For these problems, we don't need to do that. So in other words, I don't need to replace u with this. And you could do that if you wanted to, but if you did it, you would have to change these numbers back. Okay? But there's no point in doing that. It really just makes it harder. So I would just leave it as this, and let's go ahead and go with that. So we need to evaluate this definite integral. So how do we do that? We do our setup. The top one goes in first. Bottom one goes in next. And then we evaluate. So -1 to the 4th power is 1/4. -3 to the 4th power is 81 over 4. And when I subtract those, I get -80 over 4, which is -20. Okay? So two new things that we have to be aware of when we do u substitution with definite integrals. First thing is you need to change your limits. And you do that by plugging it into your u equation. The second thing that's different about it is you don't need to switch back to the x after you integrate. You just leave it because you changed even the limits turned into u values, so it's okay to leave it as a u value. Okay. So now you might be wondering, well, why did we switch it back to x last time then if we don't need to do it here? Well, because the problem was originally an x, had x's in it, so our answer has to have x's in it. For this one, since we're going to numbers as a final answer anyway, what variables we end up with are irrelevant because we end up with number answers instead of variables. So that's why we don't care about switching back for definite integrals. Let's go ahead and take a look at number 2. All right, so step 1, u is equal to 2x squared plus 4. Step 2, find the derivative with respect to x. Step 3, get the dx by itself. Step 4, do your u substitution. So we have 8x on the top. We have u squared on the bottom and du over 4x on the bottom. And then we simplify this. The x's go away. 4 goes into 8 twice. But this is where something new happens. We need to put new numbers here. If you guys write the old numbers here at this point, you're now wrong. So you need to make sure that you put the new numbers at this step. After you do the u substitution, as soon as you start getting rid of x's, those numbers need to change. So here I'm going to ask you guys to pause the video and see if you guys can put the new numbers in there. And when you're done, I'll tell you what you should have gotten. So if x is 2, I would plug that in up here for x to find the u. 2 squared is 4, times 2 is 8, plus 4 is 12. So the top becomes 12 now. Now I need to replace this x with a u value. So if I plug in 0, I get 4. So my new numbers are 12 and 4. All right, so now I've got this. I'm just going to rewrite it so it's not so ugly looking. All right, from here on out, guys, there's really not much new to do. Why don't you guys go ahead and pause the video here, see if you can finish the problem, and when you unpause it, I'll have the solution up for you. All right, so I get 1/3. So I'll explain my answer here now to you. So the first thing I did was I rewrote the problem so that the u squared is not in the denominator anymore. And then I did the power rule to integrate it. Notice the integral's gone and I have brackets instead. Next, if you're going to be plugging numbers in, you don't want negative exponents, so I rewrote this. So the 2 is going to stay on the top. The -1 on the bottom just makes the fraction negative. And the u to the -1, I'm just going to move that to the bottom with a +1 exponent now, which you don't need to write. So the answer, if you simplify that, rewrite, it would be -2/u. And then we go ahead and plug it in using the fundamental theorem of calculus there. 2/12 is -1/6. Well, -2/12 is -1/6. The double negatives here become positive, and 2/4 is 1/2. And when you add -1/6 to 1/2, you get 1/3. If you need me to work that out for you, I can do that real quick, but that's basically the final answer. So you have -1/6 plus 1/2, right? So we need to get a common denominator. Oops. And then when you combine the numerators together, -1 and +3, you get 2/6, which reduces to 1/3. So there you go. All right, so that's how you do integration with a definite integral. Why don't you guys try one of these problems on your own from beginning to end? I don't think you need to necessarily do both of these. You could probably get away with doing just one of them. Let's go ahead and do number 2. And we'll leave it at that. So go ahead and pause the video here and do the entire problem all on your own there and see what you guys get. All right, guys, so first few steps you guys probably got all on your own there. Nothing new there, but I want to draw you guys' attention to the limits. Make sure that on step 4 you guys have 5 and 3 for your limits. You get that by plugging in the 1 and the 0 there into your u equation, and that transforms them into 5 and 3. Little thing that I missed when I did this the first time, you'll notice that I put in red up there a negative. Man, I missed that, and I bet some of you guys did too, that little negative there. So if you missed it, don't worry about it. You didn't get it wrong. I mean, you did, but it's not a calculus problem. It's an oversight. It's not a big deal. So if you forgot the negative, you would have the same answer as me, but just a positive instead. Okay? It's a hard thing to catch when they do that. I hate it when they do that. But anyway, there it is. So there's a little negative chilling there. But anyway, so we replace the bottom with u, and we replace the dx with that. We reduce the 4x with the -12x, and we end up with -3. We rewrite it as a negative power instead. We integrate, and that results in a loss of the integral symbol. We put brackets in there instead with the limits on the right. The double negatives here are going to cancel, and this u is going to drop to the bottom, leading us to this. Plug your stuff in using the fundamental theorem of calculus and subtract it, and you get -2/5. Okay? All right. So now if you want to practice another one, what I'll do is I'll say pause the video and do it, and when you unpause the video, I'll have the solution for this one. But if you guys got number 2 already and you know what to do, you don't need to just fast forward this next part. But I will do one more just in case you feel like you need practice. So if you need to practice, pause the video here and I'll show you the solution. Okay, there it is. So once again, the first few steps you guys should be good on. Make sure you changed your limits in step 4 to be 0 and -2. Don't miss that little negative that's chilling there. Integration gets you to this. Fundamental theorem of calculus gives you this. The first part just becomes 0 because there's a 0 in the numerator. The second part, when you raise something to an even power, the negative cancels. So that's going to be +16/4 now. And then these two double negatives cancel, leaving us with a positive. And 16/4 is 4, so it's a +4 answer for number 1. All right. So that takes care of that. So we had two objectives today. One was to talk about how do you do definite integrals with u substitution. And now we're going to talk about the other situation. Sometimes, even though you do your u substitution correctly, you end up with an x left over sitting in there. And so what do we do if there's still an x? And that's what step 6 is going to be all about. So let's review our steps real quick. Let u equal the inside, find the derivative, solve for dx, do your u substitution, and then simplify, right? First 5 steps, nothing's changing. But when we get to step 6, if there's still an extra x left over, we're going to use our answer from step 1. I'm going to go back to that. And we're going to use that to solve for x so that we can replace that x with another u expression. So you'll see what I mean when we get there. But basically, if you have an x, there's a way to get rid of it using our equation from step 1. Okay? After that, we're going to integrate and replace and go back to just pretty much all the steps are the same after that. So no big deal. The issue here on number 6 that makes this challenging is to simplify, which I actually didn't put in the steps there. And so let's go ahead and put simplify. And I'm gonna put a guy here with a worried face, because honestly, that's what makes this hard, is after you get rid of that extra x, you're going to have a really ugly looking thing that you need to simplify, and it requires you to be good with working with fractions sometimes. So that's the issue. Okay, so the steps that I have up here aren't hard. The part that I forgot to include in step 6 is the hard part, and it's the simplifying before you integrate. So let's go ahead and do one here. So let's go ahead and bring these steps to life a little bit with an example. All right, so let's look back here. Step 1, let u equal the inside function. So here we go. I'm going to let u equal the inside function. Step 2, we want to take the derivative of u with respect to x. And that's just 3. Step 3, we want to get dx by itself, in which case we're going to end up with du over 3 equals x. All right, step 4, we're ready to do our u substitution. So I'm going to replace this with u, and I'm going to replace this with du over 3. All right, now here's how we're going to go from here with these. Notice that the x did not cancel out this time. There's nothing that's going to cancel out that x. And so that's what this problem is all about. All right, is the fact that x did not cancel out. So that's where that other step comes in that's kind of handy. Now before I do that next step though, I want to rewrite this a little bit. I'm going to leave the x and the du right there, but I want to get these other 3 things right here all together, and here's how that's going to look. I'm going to put the 2 in front of the u to the 5th, and then I'm going to put the 3 underneath of all of it. And I would encourage you guys to do that same thing. Okay, so that would be a good setup there before we go on to the next step. All right, let's go ahead and take a look at what our next is. And I think we can go ahead and call that step 5, by the way, simplifying. All right, so step 6 is where we're going to take care of that extra x that's left over. And what we're supposed to do is we're supposed to revisit this little equation that we had right over here. Okay, but we're going to do something different with it this time. I want to now solve for x. So I want to get the x by itself. So I'm going to add 5 to both sides. And that gives me u plus 5 equals 3x. And then I want to divide both sides by 3. And that gets the x by itself. So now I see that x is equal to u over 3 plus 5 over 3. All right, move on. The next thing we do as part of step 6 is Now I'm going to replace the x in my integral with what I just found out x equals. Okay, so what that's going to look like is now I'm going to have 2u to the 5th power over 3, and I'm replacing x with what I just got x to be equal to. And I got x to be equal to this. So that whole thing is what's going to come down here into these parentheses. And that's how we get rid of an extra x. Now I no longer have an x. Everything is in u's. And so we do need to simplify that a little bit as well. So we're going to distribute this in. And when you do that, you're just going to do top times top, bottom times bottom. So 2u to the 5th times u is going to be 2u to the 6th. And then 3 times 3 is going to be 9. And then we also multiply by the 5/3. So 2u to the 5th times 5 is going to give me 10u to the 5th. And then 3 times 3 once again on the bottom there is going to give me 9 again. Okay. Now, once you've gotten to that point, step 7 is to go ahead and integrate. So I think I'll start fresh up here real quick. Okay, so now we're ready to integrate. So with integration, we're going to add 1 to the power, which is 7. And then we're going to divide by that number. Now there's already a 9 in the bottom, but that's okay. I'm just going to put a 7 down there now also. Same thing goes here. I'm going to add 1 to its power, which is going to give it a value of 6. We have a 9 down there, but now we're going to put a 6 down there also. And we don't want to forget our plus c. All right, let's go ahead and simplify it a little bit more if we can here. So first of all, I'm going to just put 9 times 7 is 63, right? So this is 2 over 63. And I'm going to go ahead and just put the u to the 7th on the side there now. Plus 10 over 9 times 6 is 54. And I'm just going to put the u to the 6th on the side now. You could keep it on the top as well if you want to. I'm just going to move it to the side like that. My first fraction does not reduce. 2 over 63 does not reduce. But 10 over 54 does reduce. We can fix that. So let's reduce that a little bit. Let's see. I know 2 goes into both of those. So that'd be 5 over 27. And then the last step, step 8, I'll label that now. But step 8 is to go ahead and put the u back in. So remember, we want to replace the u with what u equals. And u equals 3x minus 5. So my final answer is going to be 2 over 63 in parentheses. Instead of u, I'm going to have 3x minus 5. And that's to the 7th power. Plus 5/27. And once again, instead of u, it's going to be 3x minus 5. And now it's to the 6th power. And then we still have our plus c. And there's our final answer there. Okay, so that's how you handle a situation where you have an extra x left over. You have to go back to the original equation, solve for x, plug it back in, and then simplify and integrate. So I have a student practice here, but what I'm going to do is I'm going to treat this one like a guided practice. So here's what I want you guys to do. I want you guys to do the first 5 steps, pause the video here, and when you're done, I'll have up my first 5 steps. Now the first 5 steps have nothing new to them. They're all the same. Okay, so before we move on to step 6, I want you guys to notice my answer here. Check your work. Make sure you're with me on step 5. Notice how I wrote my answer too is step 5. The du has to come last, and then I like to put the x there. Okay, right before the du. Everything else that was there, the 5 and the u to the 5th, or if there's a number next to the u, that too, everything gets put together as one fraction in the front. Okay, so that's how I would recommend writing your answer. Okay, it's always going to be the du, the x, and then everything else as one fraction. That will make step 6 slightly easier, okay, if you set it up that way. All right, so now I want you guys to go ahead and do step 6 now. Step 6 has a lot to it, okay, so if you need a reminder, what step 6 is you're going to go back to your equation, you're going to solve for x, and you're going to put that here where the x was. Pause the video. When you're done, you should see the solution. Okay, so here's step 6. We start with our equation from step 1, and we solve for x, and this is what we get, minus 3 divided by 5. And then we're going to replace this x with this expression. Well, not the whole thing, just this side, right? And so that results in this thing here. And after you distribute your fraction in, you get this. So now we're going to do step 7. And step 7 is where you're going to integrate. That's where you add 1 to the power and put that on the bottom. So don't forget your plus c as well. So go ahead and do step 7 and pause the video. When you're done, you will see the solution. Okay, so here's the final result down here at the very bottom. But the first thing we do is we add 1 to 6, you get 7, and put that on the bottom. Add 1 to 5, you get 6, put that on the bottom. And then multiply 25 times 7 and 25 times 6, and you get 175 and 150. And then the 3 over 150 reduces to be 1 over 50. And so you end up with u to the 7th power over 175 minus u to the 6th power over 50. And then of course we have our plus c. The last step is step 8, which I don't think we really need to have you guys pause the video for. Step 8 is just replacing the u with what u equals. So we have u to the 7th over 175 minus u to the 6th over 50 plus c. And u was our inside piece there, which is 5x plus 3. And that's one way you can write your answer. The other way you can write it is as fractions multiplying the parentheses instead. And there you go. All right, so I think I'll throw one more of these at you guys before we call it a day. I don't have any problems here, but I'll just make one up really quick because I think that it's something you guys want to practice. So here is another problem for you guys. So go ahead and try it and pause the video. When you're all done, check your answer, see how you did. All right, guys, so there is your results there, steps 1 through 8. So u equals 2x plus 1. The derivative of u with respect to x is 2. Solving for dx, we get du over 2. U substitution gives me what we have there in step 4, rearranging it so that everything that is not the x or du is moved to the front as a fraction. Step 6 is where we go back to the original equation in step 1 and solve for x, and then replace the x from step 5 with what we got here, and this would be the result, and then we need to distribute it in to get this, and that's the end of step 6. Step 7, we go ahead and integrate by adding 1 to the powers and dividing by that number, and then we simplify, we end up with this, and then we go back and replace the u with what u equals, 2x plus 1, and the two ways you can write your answer are here and the one underneath of it. So that is that for the day. That's all there is to lesson 2.5, and we'll see you guys next time.